Hi, everyone.
Hi.
So I'm here with Bijan, head of product at O1 Labs. I'm Brandon, first engineer at O1 Labs. And we're going to talk about a high-level overview of Mina and the product roadmap. Yeah, so I'm going to go over the overview first. This is quite high level. You'll hear more details throughout the day. So let's just get started. Mina is a layer 1 protocol. It must be said. So here it is. But we're going to talk about other things. Mina is powered by a succinct blockchain. Let's talk a bit about that. Let's talk about the SNARKs that make it possible, and a bit about recursion. Let's talk about the consensus mechanism in Mina, and then this unique Snark Marketplace and Snark worker role that's unique to Mina. Why do we have it? What is it? And what problem does it solve? Okay, so succinct blockchains. Mina's blockchain is less than 22 kilobytes. It's hard to believe this, but it is true. We actually published a blog post recently called the 22 kilobyte technical reference, and it goes in very much detail about precisely defining what we mean by blockchain here, how we calculate the number, and you can go there if you want to learn more. But it's there. So that maybe that doesn't tell you much about why this is good, right? So what does this succinctness buy us? Well, it means no matter how many transactions are going through the network, no matter how many blocks have gone through the network, we remain at this small size. And this is true not just for these like ideal, super lightweight 22 kilobyte nodes, but even for the nodes that participate in consensus, it's much quicker to sync. And as the network functions, as the network goes on and lives throughout the hopefully many years, the amount of data won't scale with the number of transactions or blocks. It will remain constant with respect to those. It's awesome. Now, SNARKs are what power this succinctness. So we should talk a little bit about them. I'm sure we'll talk about them a lot today. So it's an acronym. It stands for Zero Knowledge, Succinct, Non-Interactive Argument of Knowledge. Zero Knowledge we learned about in the last talk. Succinct, well, you heard in the context of blockchains, in the context of these proofs, it means even if the statement itself is quite complex, the proof object and associated data is small, and verifying it is very fast. Non-interactive means that in a single proof object handoff, a verifier can verify that proof is true without having to go back and forth with the prover. Argument, well, cryptographers will get mad at me by this explanation, but let's just say it's a proof with a little bit of non-determinism, just a tiny bit. But for all intents and purposes, it means proof. And then this of knowledge bit. So this is interesting. These statements, they're existence proofs. They prove that there exists something, but the prover actually knows the thing. The prover doesn't just know that it exists somewhere in the world. The prover has it in front of them, and they must have it in front of them to make these proofs. So it's a proof of knowledge of that thing. Now, all of this is probably very abstract. Let's think about it from another angle. The SNARKs let you prove statements of the form there exists some data such that there's predicates that hold on the data. So like there exists a PDF file such that its hash is X. Or what's interesting with SNARKs is you can say there exists some other proof such that the proof verifies. And then you have this crazy self-referential concept going on, which this also might be hard to understand. But there's this awesome anecdote, metaphor, story way to explain this that I think I got from Isaac a long time ago. So the idea here, imagine that you're taking a picture with a Polaroid camera, okay, of some scene. Doesn't matter what it is. Take a picture. Out prints a picture, and we put the picture now in front of the scene. And then we take a picture of the picture. Out comes this picture of a picture. We put it in front of us again. Do the same thing. Now we have a picture of a picture of a picture, and so on and so on and so on. And if you think about it, in this single photograph-sized rectangle, we have evidence that many pictures were taken, even though this picture is the same size as all the other ones. And if you think about this in the context of SNARKs, in the context of Mina's blockchain, you can imagine like we have a proof of the first block in the blockchain, and then we take a proof of that proof and the new block, and it's the same size as the first proof. And we do the same thing again and again and again and again. And whether it's 1,000 blocks or 1,000,000 blocks, the proof is the same size. And it's these recursive SNARKs that powers Mina's succinct blockchain. Consensus. Let's talk about consensus. Mina is proof of stake. That's great. It's green, proof of work, electricity. This is in the zeitgeist these days. Lots of protocols are proof of stake, though. What's unique about Mina's proof of stake protocol? Well, let's talk about it at a very high level. Vanishri will talk about it in more detail later. So it's called Ouroboros Samasika. And Ouroboros Samasika is decentralized, inclusive, and scalable. Okay, there's no limit on the number of participants. The communication overhead is optimal, I would say. When you're producing a block, no one knows you even exist until you present the block that you produced. There's no need to sort of coordinate beforehand. It's succinct. It works in this setting where we don't have long-term history. But in that setting, it can still resolve short-term forks, long-term forks, and make sure the network still maintains consensus. And it's provably secure, even in the context of no slashing, no bonding, or other harsh penalties that other proof-of-stake protocols typically have. So that, in turn, just makes it less scary to get started and more inclusive. All right, Snark workers and the Snark Marketplace. All right, this is this very strange concept. And I want to sort of motivate why we have this system in Mina by running us through a thought experiment. Okay, so let's try and build Mina protocol from the beginning. And we go and do a bunch of engineering. And we run into an issue, though. So we run into this issue where creating proofs for the transactions inside blocks takes a bit of computational effort. And we don't want block production to require supercomputers. So if a block producer had to make the SNARKs for all the transactions in a block when it makes the block, then block production would need supercomputers. This wouldn't be inclusive, and this would lead to centralization because many people can't afford these super powerful computers. So we want this work to be done on commodity hardware. And so to do so, rather than having it be done by one actor all at once, we can spread it out over the network. And then it'll work. Then we can do this work on computers that all of us can afford. That's exactly what this Snark Marketplace does. It introduces a marketplace to incentivize performing these proofs of transactions across the network. And we need a marketplace because, remember, in a decentralized network, there's no trust. The best way to coordinate folks is to have a market. Snark Marketplace is the name. It's a portmanteau. It's really fun. Snark Marketplace. That's why it's called Snark Marketplace. It's just a fun word. Okay, so what the Snark Marketplace does is it lets us decouple the hardware requirements of the block producer from the number of transactions that the block producer is putting inside the blocks. So whether there's 1 or 1,000, the block producer hardware doesn't have to change. And all that work can be done by the network in parallel. So how does the Snark Marketplace work? Well, you can look at the economic white paper for Mina to see like a really nice diagram and more detail. I'm just going to cover it at a pretty high, rough level. So block producers, they buy SNARKs for older transactions that block producers have queued up in order to add new transactions that the block producer earns fees from to this fixed queue or buffer, or you can imagine like a shelf of a fixed size. This shelf is full, and I want to put transactions in that shelf so that I can earn transaction fees. But to do so, I have to take things off the shelf. So the block producer, they put transactions on the shelf, earn the fees. They do not create proofs for those transactions in this block. The other nodes in the network, they gossip around the blocks. And so everyone can see this new shelf of work, or the new portion of the shelf that's been replaced. And Snark workers, probably running on commodity hardware, a single Snark worker can't do all the work at once. But they take some of it off the shelf. They crunch some numbers, create a Snark proof. They embed their public key and a fee inside the proof using a signature of knowledge. And what this does is it makes this proof, this fee and public key, it's baked in such a way that if you try and tamper with it, you break the whole proof. So the only way to compete is to make a Snark for cheaper. And then the loop closes. The block producer, they buy the SNARKs from these Snark workers. And if there's more than one available, they take the cheapest one because they want to earn the most tokens. And the cycle repeats and the network runs and that's how it works. So that's Mina. There's the overview. We talked about how Mina is a layer 1 protocol. It has a succinct blockchain. It's less than 22 kilobytes in size. It's powered by zk-SNARKs, including these interesting self-referential recursive use cases of them. There's a proof-of-stake consensus protocol called Ouroboros Samasika. It's decentralized, inclusive, and scalable. And Mina introduces Snark workers in a Snark Marketplace in order to keep the network inclusive and not require supercomputers on our block producers. So I'm going to hand it off to Bijan now, and he's going to talk about the roadmap.
Hi, everyone. I'm Bijan, head of product at O1 Labs. Very excited to be here. Thank you all for taking time from your Sunday to be here. We really appreciate it. And the month of March has really been exciting for us because we're at a really interesting point in the history of Mina. I'll go over that in a little bit more detail. I'll talk about the product strategy, what we think should be our focus right now, some of the principles that help us make sure that we're moving in the right direction at all times, the product roadmap, and finally, what the 2021 priorities look like for us. So the road to mainnet has actually been a pretty long one. And the reason for that is we started with solving the hard problem of having a fixed size blockchain using recursive SNARKs. As you can see, we've done multiple test nets. Our last test net, Test World, which was the adversarial test net, got completed in just a couple months ago. And now we're in mainnet. Transactions are happening enabled by recursive SNARKs, creating a 22 kilobyte blockchain. And this kind of allows us to really think about the product strategy when we zoom out and think about where we want to go in the long run. And the way we've been thinking about it is that we wanted to do the hard work at first, set up the foundation for scalable decentralization, the type of blockchain that scales without increasing the size of the blockchain, that allows for as many number of nodes get connected to it if possible, that allows for any type of device to connect to the blockchain without having to trust another third party. And now we're in this point of transitioning into the second phase of our strategy, which is unlocking the use cases of Mina that we think are unique to the Mina protocol. And we think that by enabling the developers to build applications and tools on top of Mina, we're able to really bring that to a large scale of users out there. And we're in this phase right now. We're kind of getting into the phase two. This is going to require us to work closely with the developers. I'll talk a little bit more about that. And then once we have an idea of what are some of the use cases that are emerging and what are some of the needs that we're noticing need a lot of attention, we're at a really good point to start thinking about scaling rather than kind of taking the other way approach that we've seen some of the other projects take, which is they start with scaling and they don't have a lot of basically use cases or a lot of traction on their protocol. So our approach here is really to try to kind of follow the use cases and really try to scale the protocol and the tooling and everything else that goes with it based on those use cases. So in terms of priorities for us, what that means for us right now is our focus is really driving meaningful usage of Mina. And Evan talked briefly about this on the keynote, and Emre will discuss this in more detail, but this is really through the usage of this concept of snaps, which is snarkified dApps, and that allow the users to verify some sort of a private computation that's happened off-chain without having to trust any third party. And this is something that's pretty unique to the Mina protocol that we think has a lot of meaningful use cases. And that's going to be really our focus in the month and years to come until we feel that there's like right amount of usage and demand in that space. And in order for us to make sure that we're moving in that direction, we're staying focused, we want to share a few principles that we want to follow and hold ourselves accountable for. And I think it's worth mentioning here with the broader community. And the first one is we must make promises that we can keep. And what this means is that instead of taking this approach that a lot of projects in crypto have traditionally taken by coming up with 5-year roadmaps or 10-year roadmaps or even 20-year roadmaps, we're going to make very clearly defined promises with immediate milestones that are measurable, that the community can say whether or not we've been able to achieve them, whether or not we're moving in the right direction. And they also allow us to iterate based on new information coming in. They allow us to make sure that if we see some sort of a traction in one particular part of the ecosystem that needs immediate attention, we're able to cater to that. And this approach of focusing on clearly defined immediate milestones makes us more nimble and more lean and at the same time ensures that we're moving in a direction that the community can measure and confirm that it's the right direction that makes sense with the broader community. And one of the benefits of that is it allows us to implement the second principle of Mina, and that's really following the ecosystem, focusing on the meaningful pain points that we notice exist in the community, whether it's coming from the developer community needing more tooling, or it's the node operators needing more stability, more throughput, or better tooling that helps them run better node operations, or it's the users that are really using Mina through some Snap applications that are connected to their, let's say, phone or browsers. And in order for us to deliver that, in order for us to really follow the ecosystem and address the needs that we notice and need immediate attention, we need community involvement. And I think the community of Mina is one of the very strong benefits of our protocol. We have a very strong community that is highly engaged. You can check out our Discord channel and kind of see that for yourself. And that allows us to really think about unlocking that potential by involving the community in protocol development, building tooling that enables a broader developer community to build things on top of Mina, and also enabling them to build snaps that can be used by the broader audience of Mina. So this is going to be another one of key principles for us, because we think that by unlocking the potential of the community, we're able to increase our product velocity significantly when it comes to product development. Now, what does that mean for us in terms of roadmap? Like I mentioned earlier, we're at this interesting phase where we've recently launched mainnet. We've come up with the Succinct blockchain. We have a Genesis program made up hundreds of Genesis founding members that bring security and stability to the network, and they participate in block production. Transfers are enabled from the beginning, and that's great because people can actually use the network and they can see how it actually operates. And now we're shifting into phase 2, which needs us to work closely with the developers. It needs us to build a lot more tooling for the developer community. It needs us to build some interesting capabilities such as composable snaps, which Brandon mentioned briefly in his slides. It allows some interesting use cases that have not existed up until now. And the Snap Developer Program is also one of those projects that we're very excited about. We think it's going to enable the Snap developers to build more interesting applications on top of Mina in collaboration with other members of the community. And Mina Phase 3 is really when we start scaling around those use cases and those things that we think are significantly important. And one of the important parts of Mina Phase 3 is enabling the mobile and web full nodes. We know that the community is very excited about this, and this is really when we're able to bring Mina to the average users with any phone device, with any browser, to take advantage of Mina. And finally, on-chain protocol treasury, that's going to be something that's going to be relevant to us in Phase 3. What that means for us in terms of priorities is that for 2021, we're going to be focusing on the developer community, like I mentioned briefly earlier. And this is something that hopefully the community can hold us accountable for by the end of the year and see if we've moved in the right direction. We think that supporting the ROS implementation is very important. It helps us to also bring the concept of web and mobile full nodes into reality with the ROS implementation. Snaps is something that's been in the work for a while, and as Evan mentioned earlier, our partnership with Teller Finance is the first step towards that. But Snap's going to be one of the key areas of focus for us in 2021, and basically enabling more demos and actually more real usage of Snaps in 2021 is going to be important for us. And in order for us to do that, we need a lot more tooling. We have a lot of interesting tools that have emerged over the last few months. We're very excited about them. There are tools that help the node operators perform better. There are tools that help any node operator to know how the network is doing, or there are block explorers that are out there. There multiple wallets that are being built right now, which is great. But we think that with snaps coming to reality, tooling becomes more important, and we really need to think about that and make sure that user experience for our developer community is great. And as more developers come into the ecosystem, it becomes more and more important for us to think about things such as network performance improvements, increasing basically improving some of the key metrics that we think matter to the ecosystem at that particular point in time. And improving the hardware requirements, I think that's going to be one of those things that's going to be important for us. We have a pretty good idea of what we need to do there to make the network even more inclusive than it is now, so that more block producers can connect with less hardware requirements. It's going to be something that's going to be exciting for a lot of the block producers, and this is something that we're going to be focusing on in 2021. That is our presentation. Thank you very much for joining us. We're very excited about where we are with Mina protocol. I think the month of March was a key milestone for the crypto community as a whole. We've been able to bring a fixed size blockchain that might have sounded like a crazy idea just a few years ago to the market. And I think now our focus is going to be really working with the developer community and the broader Mina community to scale the ecosystem. And we're looking forward to working with all of you to have a healthy, collaborative relationship that is going to help us grow as an ecosystem.
Yeah, I can't add anything to that. That was fantastic. Thank you. Thank you, everyone. What is the difference? It's something around this. What is the difference between Ouroboros consensus protocol used in Mina compared to ADA or Cardano, specifically in real world use, performance, and flexibility? Will Mina accelerate faster adoption than what is already in the market right now? Well, I don't know about the latter one. That's a very, you need to predict the future to say that, but I can comment on the differences in the consensus protocols. So Ouroboros Samasika, I mentioned this maybe too quickly, but well, in Ouroboros Genesis, which I believe is the latest version of Ouroboros, though they keep iterating. But even in any of Cardano's, ADA's, Ouroboros's, IOHK, whoever owns those, there's the long fork rule requires access to history. So you actually have to, in their Ouroboros, have exactly when were blocks produced from the point of the fork, even if that's sort of months ago. And on Mina, we were able to, well, with Ouroboros Samasika, we were able to take that rule and get it to work in this succinct context. So that's like the main difference. And then also, I guess, in practicality, in the implementation, Ouroboros in Mina is also, it's not just implemented on like the Turing machine computer, but also in the SNARK circuit, which was it's quite interesting. If you want to dig into the code, it's all open source. Yeah, in terms of real world usage, we'll see what happens in the real world as Mina grows. So hopefully that's.
All right, I can try to pick one here. I think the question is, how much stake does a block producer need to be sustainable? Is it 66,000 Mina? To be honest, the answer to that is you can have as many tokens to start a block production node, and because your portion of your likelihood of winning is going to be a kind of relevant to what percentage of staking you represent in the network. That kind of takes care of itself. You can really start with a small amount, doesn't have to be 66,000, and the rest of it, yeah, it's up to you. It's really dependent on what sort of hardware you have and how much it's costing you, and you can kind of do the math based on the likelihood of you winning and knowing what the reward amount is going to be. I think we're right at time. Thank you so much, everyone. We're very excited about what's ahead of us and looking forward to seeing the rest of you.